So I'll start with the concept of retrieval augmented generation, which is commonly known as RAG. RAG is an architectural framework designed to like optimize the output of a large language model. Yeah, and so it works by like referencing an authoritative knowledge base like outside of the model's initial training data before generating a response. And so if we look at the let me do it like this. If we look at the diagram on my screen, right, we can visualize this flow. First we have the user query, and instead of sending this straight to the large language model, the system like uses a retriever, and so this retriever searches like a vector database which holds like our external like knowledge, right? And so to find documents or chunks relevant to to this specific query, right? And then next is I'd say like the critical step, augmentation, right? So those retrieved factual chunks are then added into the context window of the prompt alongside the original question, and then the large language model generates an answer based on that specific provided information. uh, why is this necessary? I'd say is let me actually shorten this here to be able to read the questions as I go. Yeah, like so. Why is this necessary? Reg is vital for enterprise applications because like standard standard large language models are frozen in like time based on their like training cutoff, I'd say. And so they don't know about real-time events or proprietary business data. So RAG effectively like acts as a bridge to external knowledge, like grounding the model in facts. And so this is like the primary method used for like hallucination mitigation, right? So ensuring like the model cites actual sources rather than inventing plausibles sounding incorrect information. Um, so yeah. See here, let me cut this off. Foundational model selection. Okay, so how do I can I cut this as well? Okay, this it's better like this. Um, let's say how do I like approach right choosing like the right pre-trained foundation model, like you know to me like there's no like single best model, so it is always an exercise in balancing like trade-offs like primarily between capabilities, latency, cost, right? And so my approach starts with analyzing the task type and the environment, and so if the task requires like complex reasoning, deep analysis of like massive documents, or nuanced creative writing, I prioritize a large powerful model like GPT-4, or Claude 3, I'd say. And so then I accept that API, I accept that the API cost will be higher and inference speed will be slower because like accuracy in this case like would be like paramount. But then if the task is like high volume like classification, like simple data extraction, or requires like running in a secure like air gapped environment, I yeah I'll choose a smaller open source model like like Llama 3, Mistral, like yeah. And Yeah, see cost, context, window size, model licensing. The key factors like key factors like the context window size and like the model licensing also play a huge role. Like you wouldn't use a massive, expensive model just to classify like sentiment, and you wouldn't use a small, fast model to summarize like 100-page legal brief. Um, you know, but yeah. So see here. Temperature. Um, let's see here. Temperature. In simple terms, temperature like controls the the randomness, or I guess creativity, of the model's output by like influencing the probability distribution of the next predicted word. And so a high temperature means like the model takes like more risks, like leading to like a diverse, creative, and sometimes even surprising outputs. Whereas a low temperature makes the model deterministic. It will consistently like pick the most statistically like likely next word, like leading to focused and like a more conservative text, right? Um, and so if I have to explain like the impact of this with a concrete like experiment I conducted recently, I said, I was actually developing a text generation script using a foundation model API. And so the goal was like to demonstrate how different settings affect a large language model, um, like how a large language model handles like open ended in a sense. And so I set up the model with like specific prompt, right? And so the issue was that it was with the default low temperature setting. I don't remember very well. I think it was like what did I start at point two or point three? I think it was point two. But the model was like what was like stuck in safe loops, right? It kept outputting very generic, repetitive cliches. I don't remember the text, but I think it was like the secret to happiness is family, 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 something like that, right? Or the secret to happiness is to be happy. I think yeah, that was an input text. The secret to be yeah, the secret to happiness is to be happy. I think that was like the prompt or something. And so it was grammatically correct, but boring and repetitive. And so to fix this, I modified the script to run, um, was it A/B testing? Like I remember, first because I remember I first confirmed like the output of point two, then I cranked the temperature up to like point seven, point eight. Yeah. And so by raising the temperature, I was essentially like forcing the model to consider like less probable words in the distribution tail. The result was like, the impact was, I say, immediate, um, and drastic. I'd say like at point seven to point eight, like the output, transformed from a cliche into a unique, like almost, you know, yeah, I just I say like unique paragraph about like finding. I don't remember the full text that he showed, but it was very well organized and made sense. Like it had sense, and so like by adjusting that single parameter, like I successfully shifted the model from a predictable completion engine into like a creative writing